Hello students, welcome to AIMS India online classes. This is a chemist session. Here we are discussing about the chapter Is Matter Pure? So in this session we are going to say about different types of solutions. First of all, what are solutions actually? A homogeneous mixture of two or more substances is called a solution. In a solution, there is a homogeneity at the particle level. Usually, we think of a solution as liquid that contains either a solid or liquid or a gas dissolved in it. So generally, the solutions will be in the liquid form, what we know. So in that liquid, either some solid or liquid or gas will be dissolved in it. That we call it generally solution. However, this is not true. Yes, not only liquid solutions. We can have a solid solution as in the case of alloys, isn't it? Yes, not only liquids come under solutions. There will be some solid solutions also. For example, as we discussed in the earlier classes about alloys. What is an alloy? An alloy is a mixture of two or more solids or two or more metals. So generally metals are solids. So the mixture of two or more solids is becoming an alloy. Now it is a homogeneous mixture of two solids. This comes under a solution also. So alloy is a solution of two or more solids. Now what we thought earlier, solutions are generally liquid components, liquids that contain some dissolved solid or liquid or gas into it. But actually, not only liquids, the solutions may be in the liquid form, solid form, even in the gaseous form also. For example, if you say air, air is a solution of different gases, isn't it? Okay, that my solution might be in any state, not only in liquid state. For example, as I told now, air is a mixture of several gases. So there, the gases are mixed in gas form. For example, atmospheric air contains nitrogen, oxygen, carbon dioxide, water vapor. These all they are mixed in one another in the homogeneous mixture form. So air is a homogeneous mixture of number of gases. Its two main constituents are nitrogen, which is 78%, and oxygen 21%. So these two are mixed in the homogeneous form. So it is a mixture and it comes under solution form also. So air can be called a solution of several gases. Okay. Now what can be called these components? Components of a solution. The substances present in a homogeneous solution are called components of the solution. A solution basically has two components. They are solvent and a solute. Yes, majorly solutions will be having these two components. The substances present in a solution are called components. Generally, solutions will be having two major components. They are solvent and solute. What is solvent? The component of a solution which dissolves the other components in it or in itself is called solvent. A solvent is a larger component of the solution. For example, a solution of sugar in water is a solid in liquid solution. A solution of sugar in water is a solid liquid solution, isn't it? Here, sugar is a solid substance, water is a liquid substance. So the solution of sugar in water is a solid liquid solution. In this solution, sugar is a solute and water is a solvent. Generally what we take water in more quantity. Into that small quantity of sugar will be added generally. So here the component which is dissolving other substances into it is called solvent. So in this case, sugar in water solution case, water dissolving sugar into it. So water comes under solvent. And we can say the component in the larger quantity in the solution is called as solvent. So generally in the sugar water solutions, water will be in the larger quantity. So water comes under solvent. The other one, which is in the smaller quantity, is known as solute. Let us say about that also. Solute. The component of the solution which dissolves in the solvent is called solute. Solute is a smaller component of the solution. Yes, it will be the component present in the smaller quantity is called as solute. And this solute will be dissolved into the larger quantity component, that is solvent. For example, solution of iodine in alcohol known as tincture of iodine. Yes, generally we use this for antiseptic medicine. When we get any hurt, we apply this tincture of iodine. This is a solution of iodine in alcohol. So here, small quantity of iodine will be dissolved into alcohol liquid. Now here, iodine is a solute because it is taking the smaller quantity and it is dissolved in the some other component which is in the larger quantity. So here, iodine is a solute and alcohol is the solvent. Similarly, in carbonated drinks like soda, carbon dioxide gas is a solute and water is a solvent. What do they do there in carbonated drinks like soda? They take water and they add this carbon dioxide gas by applying high pressure. So some quantity of carbon dioxide is dissolved into water. So here the larger quantity one is water, so it is solvent, and the quantity of carbon dioxide, some quantity of carbon dioxide is dissolved into it. So carbon dioxide is a solute, water is a solvent in carbonated drinks. Okay, see here, when you mix this solute and solvent, we get a solution. For example, I think they have shown here a blue colored crystalline substance. Generally, it might be copper sulfate. When copper sulfate solute dissolved into water solvent, we get a copper sulfate aqueous solution. So here, smaller quantity component is here this salt. So it comes under solute. Larger quantity one is water, it comes under solvent. The mixture of these two is called solution. So we can come to the conclusion that solutions may not be always in the liquid form. Solutions might be in the solid form or in the gaseous form also, not only in the liquid form. Okay. Different types of solutions. One among them is a dilute solution, a solution in which the concentration of the solute is much less than that of the solvent. Generally, the quantity of solute we take in smaller quantity when compared to the quantity of solvent. But the quantity of solute is very much less than that of the solvent quantity. Then that solution is said to be dilute solution. For example, if we mix 1 gram of salt in 500 ml of water, see here, compare the quantities. Wait, the quantity of salt is 1 gram, whereas the quantity of water is 500 ml. It is a half liter. So the comparatively, the quantity of salt is very much less than that of the quantity of water. So the salt solution thus obtained will be dilute solution, because the quantity of salt is taken very less here. So if the quantity of solute is very much less, then the obtained solution is said to be dilute solution. Okay, if we keep on adding the solute in a solution, there comes a point when no more solute dissolves in the solution. This is called saturation point of that solution. Yes, here we have taken 1 gram of salt into 500 ml of water. When you add this salt into water, it dissolves on stirring. If you keep on adding this salt to some quantity to quantity, so after adding certain quantity of salt, we reach a point where no more salt can be dissolved even after stirring also. It remains at the bottom. That stage or the situation where no more salt is being dissolved further is called saturation point of the solution. Next, one more kind of solutions here, concentrated solutions. A solution in which a large amount of solute is called a concentrated solution. Generally, the solution in which a small quantity of solute is present are called dilute solutions. If the quantity of solute is much larger when compared to the quantity of solvent, then that is said to be concentrated solution. Generally, these terms we use at chemicals used in the laboratory. If we take acid, generally acids which we use in the laboratory are dilute acids because there where you take small quantity of acid and it will be dissolved into large quantity of water. But in the some chemical laboratories, they use concentrated acids also. There, the quantity of acid will be more when compared to the quantity present in it, the quantity of water present in them. Okay, so constant based upon the constant quantity of solute present in the solution, they are divided in, they are classified into two types. They are dilute solutions and concentrated solutions. The solution which contains larger quantity of solvent and a smaller quantity of solute are called dilute solutions. If the quantity of solute is larger than the quantity of solvent, then that solution is said to be concentrated solution. See here, they have shown diagrammatically also. If you see quantity of solute, if it is less, then that is said to be dilute solution. If the quantity of solute is much greater, then the solution is said to be concentrated solution. Okay, you can observe here clearly. In this, if you say solvent particles are more, these are solvent particles, these are solute particles. If we say in this, more number of solvent particles are there, but solute particles are very less. So this kind of solution is said to be dilute solution. If you observe this, solvent particles are less when compared to the solute particles. So it is said to be concentrated solution. Okay, these are two types. Next, saturated solution. This is one more type of classification of solutions based upon the quantity of solute again. One of them is saturated solutions. A solution in which no more solute can be added since it has already dissolved the maximum amount of solute. It can be called as a saturated solution. Yes, the solution in which no more solute can be dissolved because it has already the maximum quantity of the solute which can be dissolved into it. Such kind of solution is called saturated solution. One more, unsaturated solution. A solution in which we can add more amount of solute as it has not achieved its saturation level yet is called unsaturated solution. Yes, this is one more kind of solution in which we can add more amount of solute still because it is not at its saturation level yet. It can dissolve more amount of solute still. Such kind of solution is called unsaturated solution. Okay, solutions are of two types based upon the quantity of solute present in them: saturated solutions and unsaturated solutions. The solution which cannot dissolve any more solute still because it has the maximum required amount of solute. It has already dissolved required amount of solute into it. Such kind of solution is said to be saturated solution. The solution which can dissolve more amount of solute still is called unsaturated solution because the such kind of solutions still they did not reach their saturation level, so they are called unsaturated solutions. There will be one more kind of solutions also, third category. They have already excess amount of solute dissolved into them by heating or by stirring. Such kind of solutions are called unsaturated, supersaturated solutions. So the solutions which have excess amount of solute dissolved into them than their saturation level are called supersaturated solutions, but they are unstable. But so these are the different two kinds which we observe generally. The solutions which have required amount of solute in them as saturated. The solutions which can dissolve some more solute still are called unsaturated solutions. A solution can reach a status of saturation by adding more solute. Yes, if it is unsaturated, we can make it saturated by adding some more solute. After reaching this state, no more solute can be added. Yes, once after reaching the saturation level, no more solute can be added into it. Addition of solute after this point would result in a solid precipitate or gas being released. Yes, after reaching this saturation point, if you add still some more solute, that won't be dissolved into that solution. It will be like a precipitate at the bottom, or it evolves out by like a gas. It will be released out like a gas out. Such a mixture is called a saturated solution. Yes, the solution into which we cannot add any more solute still. That key is called saturated solution. If we add some more solute into the saturated solution, what happens? It won't be dissolved. It will be settled down like a precipitate. If it is a gas, it evolves out like a gas, but it won't be dissolved. That kind of solution is said to be saturated solution. Next, how can we prepare the saturated solution from unsaturated solution? Yes, we can prepare saturated solution from the unsaturated solution by adding continuously solute into it. So, a saturated solution is prepared by continuously adding solute to the solution until a stage is reached where the solute appears as a solid precipitate or as crystals to form a highly saturated solution. Yes, we can prepare saturated solution from unsaturated solution by adding solute continuously. So we can add solute continuously until it settles down like solid particles. So at that stage we can understand that it became saturated with the solute. Consider the process of adding table sugar or common sugar to a container of water. Yes, let us try to see how to prepare a saturated solution. If you take a container or a test tube with water, if you add some sugar into that, what happens? It dissolves into it as we know. Initially, the added sugar dissolves as the solution is stirred. Yes, if you take small quantity of water and if you add some crystals of sugar into it and if you stir it, what happens? Then the sugar added will be dissolved. It will be disappeared. Finally, as more sugar has added, a point is reached where no amount of stirring will be cause the added sugar to dissolve. Yes, at a certain stage, even if we add sugar and if we stir it, no sugar is going to be dissolved further. That stage we can say as saturation level. The last added sugar remains as a solid on at the bottom of the container. So the solution obtained then is called saturated solution. So by remaining these crystals as it is, even after stirring also, this indicates the formation of saturated solution. Okay, see here. So it is added and it is continuously stirred. At the starting, they are dissolved immediately after stirring. But after certain time, even though you stir, that added sugar crystals will be remained as it is at the bottom. That indicates formation of saturated solution of sugar with water. Okay. So what are the factors affecting the point of the saturation? One among them is with increase in the temperature, the solubility of some solutions increases. Yes, the increase in the temperature affects the saturation. For example, if you take sugar into water itself, if you take 1 liter of water, if you continuously adding sugar into that, it dissolves on stirring. But after adding certain quantity of sugar, it stops dissolving into it. Whatever the solute you further add, that sugar will be settled down in the container. But if you once start heating this solution, that is settled down sugar also will start dissolving again. Means the solubility increased by heating the solution. For some solutions, solubility increases by heating, but it is not for same for all kinds of solutions. But for some solutions, increase in temperature causes increase in solubility. Solutes which are finely divided possesses greater solubility. Yes, this is also one of the factors. Size of the solute particles. If you take larger crystals of sugar into water, they may dissolve very slowly. And if you take a very fine powder of sugar, it disappears immediately. For example, if you take sugar and glucose, if we add sugar into one beaker and if we add 1 spoon of glucose into another beaker of water, the same quantity, we stir them, which will be dissolved immediately. The glucose with the very fine particles will dissolve immediately into water, whereas the sugar it dissolves very slowly, and the solubility also will be increased for this fine particles of glucose. Okay, size of the particles also affects the solubility. If we take finely divided particles, solubility increases. The net dissolving rate can be increased by stirring the solution with which prevents the buildup of solute. Yes, it is also one of the factors. Stirring. If you take sugar into water, after some time that sugar will be dissolved. But if you stir the sugar solution with some stirrer, what happens? That sugar will be dissolved very fastly and will be ready to dissolve some more solute into it. So solubility increases by continuous stirring also. Stirring increases the solubility. Okay, now we can say from this all, so we can conclude that the temperature of the water or solvent, size of the salt or solute particles, and stirring of the solutions are some of the factors that affect the rate of solubility of a solute in a solvent. So we can conclude these are some of the factors which affect the solubility or the speed of this solubility also, that we can say as a rate of solubility, means that speed with which speed that dissolving into solvent. So these are three factors affecting it: temperature and size of the solid to solute particles and continuous stirring. These three increases the solubility speed of the solute into solvent. Okay, next let us see some examples which we come across in everyday life with saturated solutions. Let us see one among them. Beverages are one of the most widely used and loved saturated solutions, isn't it? We like beverages like some soft drinks or aerated drinks like Coke, Pepsi, and these all. What are these all containing? Some sugar dissolved into water, and into that carbon dioxide gas is passed away at high pressures. So in these drinks, water is a solvent and carbon dioxide is bombarded as a solute until the point of saturation is reached. Yes, carbon dioxide gas is passed into this water until the saturation point is reached. So these are the solutions, saturated solutions with water as solvent and carbon dioxide as solute. One more, in the kitchen, many cooking recipes involves dissolving of salt, sugar, and other household ingredients into the water, isn't it? We prepare so many food items. which contain some solutes like salt, sugar, and other household ingredients dissolved into water. This procedure is temperature dependent. As the temperature of the water increases, the solubility of the solute also increases. Okay. Next, we are telling solubility. What does it mean here? The maximum amount of solute in grams that can be dissolved in 100 grams of the solvent at a given temperature to form saturated solution is called the solubility of that solute at that particular temperature. Yes, we are telling by adding solute continuously, we can prepare saturated solutions. So if you take a saturated solution, the quantity of solute dissolved in a particular quantity of solvent to make saturated solution is called solubility of that solute at the temperature. So to say definitionally, the maximum amount of solute in grams that can be dissolved in 100 grams of the solvent at a given temperature to form a saturated solution is called the solubility of the solute at that particular temperature. Okay, so it can be given by the mathematical equation also. Solubility of a solute is equal to weight of the solute in grams by weight of the solvent in grams in a saturated solution into 100. Okay, weight of the solute by weight of the solvent into 100. This gives the solubility of that solute in the solvent at a particular temperature. Okay, if we have taken a saturated solution, if you know the weight of the solute and the weight of the solvent, then if we substitute those two, we get the exact solubility of the solute. Let us see a solved example on this. See the question here. 2.5 grams of a salt is added in 25 grams of water to form a saturated solution at 298 kelvin temperature. Find Find out the solubility of the solute at this temperature. So what happened here, say some quantity of salt is dissolved in some quantity of solvent water to form a saturated solution. Now saturated solution is formed by taking these quantities of solute and solvent. Now they're asking solubility of the solute at this temperature. So let us see the solution for this. So what is the solute of the mass of the solute given? Solute is here salt because it is taken the smaller quantity. So mass of the solute is 2.5 grams. Mass of solvent, that is mass of water, is 25 grams. Why water is solvent here? It is taken in larger quantity. So mass of solvent is 25 grams. Now we have the formula for calculating solubility of a solute. Solubility of a solute is equal to mass of the solute by mass of solvent into 100. So mass of solute and solvent should be taking the same units. Now we substitute those two. 2.5 by 25 to 100. What do we get? 10. So the solubility of this salt in water at this temperature, given temperature, is 10. Means in every 100 grams of solvent, 10 grams of salt can be dissolved to form a saturated solution. So in this way, we can calculate solubility of a substance. Sometimes they will give solubility and either mass of the solute or mass of solvent. We can find out the unknown quantity by using this formula. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for receiving latest updates on recorded videos. Thank you.